So, welcome everyone. You are tuning in to the AIA Research Academy. My name is Dr. Marian Reven, and I am on the steering committee for the Alliance of International Aromatherapists Research Academy, made possible by a generous grant through the Gat Fosse Foundation. As clinical aromatherapy grows in popularity, we look for more research. We want to support the efficacy and how aromatherapy works in people for their well-being and their health. And tonight I'm going to introduce Dr. Bruce Boynton. He has a distinguished career as a naval officer, a pediatrician, a researcher, editor, and hospital administrator. He became interested in aromatherapy while attending massage therapy school and is now a certified aromatherapist. He is the editor of the Journal of Health and Human Experience, but more importantly, he taught statistics, and so he has a handle on this. He's passionate about teaching everyone how to figure out tricky topics such as regression analysis. So without any further ado, I'm going to share my screen and share Dr. Boynton's slides, and we'll get this started. We do ask that everyone would mute while we get this presentation started. If you have questions, please use the chat. We should have time at the end for questions. Dr. Boynton is usually great about answering them. This program is recorded, and you will be able to find it on the AIA Research Academy, which we're putting the link to that in the chat on the Alliance's website, but you'll also be able to find it on the YouTube channel for the AIA Research Academy. And we want you to subscribe, like, share, and let people know that this is a great resource. And it's free. All right.
Okay, Marty, thank you so much. And you just did what I was getting ready to ask you to do, to make
Okay.
it. And thank you all for coming. This is a scintillating topic, and I know you will really enjoy it. But um, uh, statistics has a limited appeal for the general public. But after watching this presentation, you should be able to do multiple kinds of regression yourself and use it in your research. Thank you, Marty. Regression has several different uses, and so you may be familiar with the terminology, but it's used differently in different fields. For instance, in psychology, especially child psychology, it's a temporary reversion to earlier stages of development to cope with stress or trauma. And you'll see this in toddlers. Um, they're faced with a problem or a challenge that they can't uh, they can't overcome, and therefore they drop back to a earlier stage of development to try to cope with the problem. So that's in psychology. Regression to the mean, which means when extreme values of a random variable are observed, they are more likely to be followed by values closer to the mean. Here's an example of that, regression to the mean. Suppose you were decided to measure the heights of people at a basketball game, a pro basketball game. First, you start with the players, and that's going to be close to 7 feet tall. And then you go to the audience. The audience is unlikely to have an average height of 7 feet tall. They're going to be more like 6 feet or 5'9" or something like that. So when you get extreme values, they're more likely to be followed by values that are closer to the mean. Okay, but in statistics, these regression are techniques to explore the relationship between a dependent variable and one or more independent variables. Okay, next slide, Marie. Okay, so what we're going to cover is independent and dependent variables, scatter plots, linear regression with one predictor variable, correlation, linear regression with two or more predictor variables, curvilinear regression, and finally we'll touch on logistic regression. So these are all different kinds of regression, but most of these you can do very easily. Now I'm going to show you how. Next slide. Okay, there's an accompanying PDF that will list all these free internet calculators. So you can get free calculators for scatter plot, linear regression, multiple linear regression, and curvilinear regression. And these sites are listed on the PDF that will accompany this, this presentation. Next slide. Okay, independent and dependent variables. Most people think that they only work with one variable because they forget to count another variable. That variable they adjust. And the idea is an independent variable is a predictor, and it's adjusted by the researcher, and it's plotted on the x-axis, which Dr. Raven reminded me one way to remember that is X marks the spot. So the independent variable, the one that you adjust yourself, is plotted on the x-axis. The dependent variable, the variable you're trying to predict, or the outcome variable, is plotted on the y-axis. And if you see the capital Y, it's upright. So you plot that on the upright axis, which is the y-axis. Next slide. Independent and dependent variables. Here's the idea. If we know the relationship between the variables and we know the value of the independent variable, then we can predict the value of the dependent variable. Here's an example. Age and linear height. And I make the claim here that all adults, every adult, is taller than any newborn baby. Well, that's pretty obvious. Therefore, there must be a relationship between height and age. Since newborn babies grow up to be adults and increase in linear height, is somehow related to age. Next slide. Here's a scatter plot that I found on the internet. The x-axis is age in years. That's the independent variable. And the dependent variable is the height in feet. And there's some curves to this, some mild curves, but it sort of makes a straight line. You can imagine the straight line running from 1 to 20 years of age. Now, when I look at a graph, I always look for any errors on the graph or any limitations on the graph. Now you see that this graph goes from 1 year of age to 20 years of age, and it goes from 1 foot to 6 feet in height. If you extrapolated this data, you would predict wrongly that by 40 years of age, people should be about 12 feet tall. Well, that's clearly not the case. And so you you extrapolate your data, that's perilous. You should only uh, prophesy it or predict variables within the range of your observations. So these are all observations, all these points, and we can predict. For instance, we can interpolate between dots and say, well, on average, it should be between these two dots, but extrapolating beyond your observations is perilous and often will lead you to the wrong conclusion. The other example here is if you look at the origin of the graph right here, that should be 0 years of age, so at birth, but we already know that a newborn baby is about 17 to 18 inches on average, 17 to 18 inches in linear measurement. But here, so they should have had a point down there, but look at 1 year of age. The average 1-year-old is not 12 inches tall. That's wrong. Okay, so always take a look at your data, and the best way to look at what kind of regression you might or might not use is the scatter plot. And there is a website that will do these free scatter plots for you. Next slide. Next slide. Okay. So what does regression have to do with aromatherapy in the first place? Well, it's a valuable tool to understand and predict things. And the first I want to talk about is extraction kinetics. Someone told me that I'd made up that word. And it looks pretty impressive, but I probably did make it up. But here's the underlying science. If you do a GCMS, the components and the amount of the components in your GCMS are a function of the distillation time. Top notes, those small volatile molecules, will come off first, and then intermediate and bottom notes. So you have to, if you want to extract heavier molecules, you have to have a longer distillation time. The second example comes from effects on biological systems. For instance, here's a question. How much tea tree essential oil is required to kill 99% of the E. coli on this agar plate? Is it 1/100 of a mil, 1/10 of a mil, 1 mil, 2 mils? So in this case, the independent variable is how much tea tree essential oil you add, and the dependent variable is the percent of E. coli killed. And the first example, the components being a function of distillation time, the distillation time is the independent variable. And whatever component you're looking at, the percentage in the essential oil is the dependent variable. One of the things I want to say is we get into more complicated material. I don't have that many slides, so if you have a question or I haven't been clear, just ask it. You can put it in the chat, and Dr. Avon will tell me, and I'll explain. Okay, next slide. How to make a scatter plot. First, you've got to choose your variables. The independent variable, which is going to be the predictor, which you choose, is going to go on the x-axis, and the dependent variable, which you're trying to predict, goes on the y-axis. After you choose your variables, make a table of your observations, and then plot the observations on a graph and look at the graph. Next slide. Okay, here's an example. Myrcene is it's a monoterpene, but it's a relatively heavy monoterpene. It's found in lemongrass, thyme, bay, pine, and juniper berry. And we know that myrcene has relaxing and sedative properties. And so suppose you're going to distill some, say, thyme essential oil, and you want to, for your purpose, you want to maximize the myrcene content of your thyme essential oil. So what distillation time will maximize the myrcene content of your thyme essential oil? Now, in this case, the dependent variable is the myrcene content of your essential oil, and the independent variable is the distillation time. Next slide. Okay, then you write down your observations in a table, and on the left is distillation time. Now, I have to tell you that I just made up these numbers. I don't know anything about distilling thyme essential oil. So I just made up some numbers and some myrcene content in percent in the middle column. And you see for each observation, you've got two numbers. Let's take the first row. Distillation time is 10 minutes, and the myrcene content was 5%. So you have two numbers for that observation, 10 and 5. And I've put it in the right-hand column, plot. So what you're going to do is plot 10 over on the x-axis and 5 up on the y-axis, and that's going to be your observation. So let's take another example. At 50 minutes, it's 50 and 40. So the plot, you plot the point 50, 40, 50 on the x-axis and 40 on the y-axis. Next slide. Okay, and this is the data that is plotted right here, and I've drawn a little regression line through there. The distillation time is on the x-axis, and the myrcene content in percent is on the y-axis. And if you see those observations sort of make a straight line. Well, I picked the numbers so they would. And you can imagine a straight line describing the relationship between distillation time and myrcene content. That seems reasonable to explain that relationship. Now, once again, I have to point out the limitations of this graph. It should start at 0 because you don't have any essential oil. Therefore, the myrcene content is going to be 0. I should have put that point in, but I didn't. Next slide. Okay, calculating the linear regression line. We call it linear regression because it's a straight line. And first, use the free calculator on the PDF to make the regression line. Y equals mx plus b. This is the standard equation of a regression line. And okay, so y is our dependent variable, the myrcene content. So that's what we want to predict. So that has to be on one side of the equals. And if we're going to use x to predict it, x has got to go on the right side. So y and x, that makes sense. What is this m and b? M or sometimes you'll see it written as AX plus B. M here is the slope of the line. Slope means how steep it is, just like on the treadmill. You go up as you get more in shape, and you increase the slope of the treadmill, and that's the same way. We'll talk a little bit more about slope in a little bit. B is the y-intercept, where the line, your regression line, crosses the y-axis. Another way to say it is the value of y when x is 0. Okay, next slide. Okay, here's the same regression line, and I've added in the statistics that you will get when you do this regression. Here's the equation of the regression line at the top. Y equals 0.89x minus 5.7. Okay, the slope, 0.89, is greater than 0, therefore it goes up. It's a positive regression. We're going to show you an example of negative regression. Negative doesn't mean bad, it just means it's pointing the other direction. So if you have a slope of greater than 0, it goes up as x increases. Now, I'll show you something. I said before, I did not plot a observation at 0, 0 down at the origin. Therefore, if you extend the regression line to where x equals 0, it goes below 0. You see the minus 5.7? If you extend that further, it's going to be, oh, Marty, that was slick. Thank you. But that doesn't make any sense in aromatherapy. But the regression just fits the line to the data. It doesn't know anything about aromatherapy. Now, below the regression equation, you have two things, P and R squared. P stands for probability. So the probability of something happening is less than 0.0001. So there's a very small probability of something happening. A gold star for anyone who can tell me what that unlikely event is. If you don't know, you're in good company, because I ask doctors this all the time and they have no idea. Okay, the probability is very low, 0.0001, that the slope is 0. What's the slope of 0? It's a horizontal line. Right. So there is a positive relationship between distillation time and myrcene content, and it's proved by the probability that the slope is 0 is very, very small. 1 in, what, 1,000, 10,000, something like that. Okay.
So, Dr. Bruce, can I ask a quick question? Since you
Yes,
said
ma'am.
to ask questions throughout. So, is that the same as the p-value that we talk about with our other statistics?
Yes, but
Yes.
usually the p-value in ordinary statistics, the kind that you're most used to, say a t-test, is whether your set of observations belongs to the normal curve or the t-curve, or is so far out on as an outlier that it's unlikely to be a member of the, or sometimes you'll say, you'll have our two distributions different. And if the P is less than 0.05 or whatever, 0.01, it's unlikely that they are the same distribution. So it's very similar, but they're testing something different.
Right. Thank you. That's a great clarification. And the other thing that I would want to clarify was, so when you're doing the other statistics and you're looking at the p-value, and we're told having, if you have two groups that you're comparing, you want to have at least 30 in each group to get kind of an average where those groups are, and then the p-value can actually mean something. So you're saying in this case, it really doesn't mean any of that, those comparison of groups. It's just a totally different thing.
It is.
Okay.
You still have to have enough points, of course.
Okay.
Yeah. Now, below the p-value is r squared. That's the square of the multiple correlation coefficient. What the heck does that mean? That tells you how well the line explains the data. So 0.995, 99.5% of the variability in the points is explained by the regression line. That's so good, it's almost never seen. But if you have a correlation of 0.3, then there's other factors involved in the variability of your points, of your observations. So this is an extraordinarily accurate regression line. You rarely see this in experimental data because there's so many other factors involved. Next slide. Okay, types of correlation. Now, your R squared, your correlation in that sense is how close your points are to the line. So on the right hand of the screen, there's no correlation. Yeah, you could draw a line like this, but it would be uninterpretable. So R squared is going to be very, very low or close to zero. And you can run a regression line. You can, yeah, the free calculator will figure it out and run a regression line, but it doesn't mean anything. That's why you have to do a scatter plot first and look at the data yourself. Now, positive correlation means that the as x increases, the line rises. Negative correlation means as x increases, the y value falls. Negative is not bad, it's just telling you which direction the line is in. Next slide. Okay, let me talk a little bit more about a slope and the equation of a regression line. We said that y equals mx plus b and m is the slope. What does slope mean? Well, slope means how steep the line is, or another way to say it is the rise, that is the increase in y value, over the run, the increase in x value. Let's take an example. Next slide. Okay, here's the slope of a line, and this is a very easy to determine slope. If you see when x is 5, y is 5. when X is 20, Y is 20. When X is 40, X is 40, Y is 40, et cetera, et cetera. So the rise over the run will be, say, 30 over 30, 50 over 50, 40 over 40. It's 1. Now, if it was steeper, if the slope was steeper, it would be greater than 1. If the steepness of the slope was below the line, it would be less than 1. And of course, if it went into negative, the y went into negative numbers, it would be less than 0, negative. Next slide. Okay, so much for simple linear regression. Now we're going to talk about another problem, multiple linear regression. Suppose we have 2 or more independent variables, that is 2 or more predictors, and we want to predict one dependent variable. And here's an example from aromatherapy. Both tea tree and thyme are active against E. coli. Tea tree because it's got terpentanol, and thyme because it's got thymol and carbapenem are active against E. coli. So what's the best way, the most efficient way to use these oils together to kill E. coli? Well, we could do a linear regression like we've done for tea tree, and then another one for thyme, but this would not demonstrate the synergy between the essential oils. For instance, should we use a lot of tea tree and a little bit of thyme, or would it be better to use a little bit of tea tree and a lot of thyme, or whatever? This you can figure out with multiple linear regression. And there is a free website that does multiple linear regression for you. Next slide. And I went to this website and filled in some bogus numbers. And because we have 2 predictors, we have 2 X's, X1 and X2. X1 here is tea tree, X2 is thyme. And I made these in mils, 100th of a mil, 2,500 thousandths of a mil, whatever. And the third column is the percentage of E. coli that were killed. Don't worry much about the last 2 columns, the predicted Y. So that's what the equation predicts, and the residual there is just the difference between the observation and the predicted. So that's not important to us. So when you fill out this, and this is right from that free website, it gives you a p-value. Notice that they use E for some reason. I don't know, or maybe they just use the exponent. Maybe E means exponent. I don't know, but whichever way, it's highly significant. And you probably want to see a graph of this, but here's the problem. Because you have 3 variables, you have to plot it on a 3D graph. And I tried very hard to plot these data on a 3D graph and completely failed. So you won't be seeing a graph. Next slide. Okay, now we're going to talk about another topic, nonlinear regression. Previously, we only considered data that appeared on the scatter plot to fit a straight line. But what if the data appears curved on the scatter plot. Well, we could do a linear regression, but it would be meaningless because it would not describe the relationship between your variables. The most common example of data that curves is called exponential increase or exponential decay. Next slide. Here's an example. On the y-axis is the daily new confirmed COVID-19 cases. And what's getting cut off on the x-axis is the dates. But this is real data. And you might think, why isn't this linear? Well, epidemic data is typically exponential because let's say each person can infect 10 other people with COVID. So that means 2 more people can infect 20 more people, and 10 can infect 100 more people. So it builds on itself, as it were. And you see typically of exponential increase, it's sort of flat at the beginning, and then it rises faster and faster. So this is very, very common. And I'll show you some examples related to aromatherapy. Next slide. Pharmaceutical drugs and components of essential oils undergo exponential metabolism. They're excreted from the body exponentially. Well, why is that? It turns out, I'll give you a formal definition. If the concentration in your bloodstream is very high, metabolism goes fast. As it falls, metabolism goes slower and slower. In other words, the rate of elimination is directly proportional to the concentration of the substance in the bloodstream. As concentration decreases, the rate of elimination slows down, resulting in an exponential decay curve when plotted against time. Now, what I showed you before is exponential increase, but it's going to go the other way for metabolism. Next slide. Now, there's an exponential regression calculator on the PDF, and you fill it out in the same way. This is from their website. I put in, and again, I chose numbers which I thought would fit an exponential curve. So at time 0, you have 100% of the component left. And it never goes quite to 0. As I went out 10 iterations and it got down to 5%, from 100% to 5%. Now below these data points, there is it's not y equals mx plus b, it's a more complicated equation, but don't worry about that. And now I'm going to do the exponential regression. And what I chose is the metabolism of carvacrol. Next slide. Okay, and you see that the curve seems to fit the data really pretty well. In fact, R squared down at the bottom is 98%. That's extremely good. But again, the regression mechanics know nothing about aromatherapy. So I plotted, if you look up at time 0, it's 100% because we haven't eliminated anything yet. But the curve does not go through that point. It fits the lower points very well, but yeah, right there. It doesn't go through there. So that's just a limitation of, of regression itself. Next slide. Now I'm going to talk and only touch on a fairly complicated technique called logistic regression, but it's commonly used in research. So in the former regression models, we used only continuous variables. Continuous variables can take any value. So age and height are continuous variables because you could be 6.0132 whatever feet tall, or you could be 2.13 years of age. But in our previous models, we used continuous variables as predictors and as predicted. But what if we want to work with categorical variables? A categorical variable just assigns something to a category, like yes or no, pass or fail, male or female, win or lose. Those are categorical variables. Now, I'm going to use the simplest model of logistic regression. The independent variable is continuous, and the dependent variable is a categorical variable. And logistic regression will give you the probability of each outcome at each point. And the example we're going to use is pass or fail. Next slide. Okay, this is a graph of the logistic function. It always sort of looks like an S. Now, what they're trying to do is predict the probability of passing the exam by how many hours you study. And if you look toward the origin, down near 1, if you only study 1 hour, it's not the chance of passing, well, that's like half an hour or 20 minutes. Yeah, yeah, if you only, yeah, you failed the exam. You have far less than 25% chance of passing the exam. On the other hand, if you go up to the top of the graph, if you study 5 hours or 6 hours, it's almost certain that you'll pass the exam. So that's logistic regression, using a continuous variable to predict a categorical variable. Next slide. Well, what the heck does this have to do with aromatherapy? Here's an article. The use of aromatherapy products and increased risk of hand dermatitis in massage therapists. And they used a very complicated method of, they had multiple outcome variables. They didn't do it just you have it or you don't have it. They had degrees and stuff like that. So a very complicated model. And whenever you use logistics regression, I want you to know what it is because it does fall under the category of regression, but you need to consult with a statistician. Now here, this is table 3 on the right, shows the risk estimates for self-reported cases of hand dermatitis. And so you see that women are slightly more apt to get hand dermatitis than men. And if you're older, you're slightly more apt to get it. But the real values here are if you have a history of atopic dermatitis, then that is highly correlated with hand dermatitis as a massage therapist. Also, if you use aromatherapy oils in your oil-based massage, you're also more apt to get hand dermatitis. None of that should be that much of a surprise, but this is a good example of the use of logistic regression in aromatherapy research. Next slide.
Before we go there,
Yeah.
people might be wondering, what about atopic dermatitis? And probably the reason why they did this study was because people use aromatherapy products in their massage, they get their hands in it a lot. And
Yes.
this atopic dermatitis, I believe it's a form of an allergy in which a hypersensitivity reaction, such as dermatitis, occurs. So it's something that occurs over time, particularly, right?
It does. I've seen a lot of it in children. Yeah, I trained with a pediatric dermatologist. His area was atopic dermatitis. Now, I think that there is some division among physicians at really the cause. He thought that it was, whatever the cause, it was a loss of a protein in the skin that uh, that kept moisture in the skin. So these children, when they would wash with soap, they would their skin would dry out a great deal, and then they would scratch because it was itchy, and then they would their fingernails being dirty would inject themselves with staph or strep, and they get impetigo, and it's just a mess. Certainly, atopic dermatitis is much more common in um, allergy prone individuals. But if there is a consensus on the actual cause, the physiological cause of atopic dermatitis, I don't know it.
Thank you. It's
You
just
bet.
one of those things that's very interesting to those that work in the essential oil, with the essential oils and their massage and aromatherapy. So thank you.
Right.
Please continue.
Okay, next slide. Okay, so what we've covered, regression attempts to discover the relationship between two variables. The independent variable, which you can choose as an experimenter, is the predictor, and the dependent variable is the one you want to predict. Scatter plots are the first step in exploration of this relationship. I can't emphasize that enough. I see researchers that just go right to regression and they get idiotic results because they did not look at the data. If the data appears to make a straight line, then try linear regression. If the data appears to curve, try exponential regression. And the calculations will be done for you by those free internet websites. P tells you the probability that the slope is 0. R squared tells you how well your line fits the data. Next slide. And any questions?
Wow. Thank you, Dr. Bruce. That was excellent. And I had questions all throughout. I've written things
Well,
down.
please
I've
fire
read
away because probably some other people have those same questions.
They probably do. So let me go ahead and stop sharing and come back out here and ask the audience, how about it? Do you have questions for Dr. Boynton? He's done a great job explaining this, but there could be lots of things. So if you would just go ahead and unmute yourself and ask your question. We have about 5 minutes left.
I will add that you can go and get 1 hour of CE, and you take a little 3 question test. The test is easy.
It is easy. And thank you so much for mentioning that because the link to everything is in the chat to go to the AIA website. Thank you, Carol. And to go to the YouTube channel. Once we get all this branded and up on the YouTube channel, it will have a link to take you to the AIA website where you can make a free account and join the AIA Research Academy and have access to lots of statistical analysis videos, mentoring, use of the treats tool, and lots of other topics, how to deal with the institutional review board or ethical reviews. On the YouTube site, there are 30 videos. Many of them are shorts, but then we have full-length videos about things. So we want you to go out, like, subscribe, share. And if there are no other questions, I just want to say how remarkable it is that for the first time in my career, I haven't been a researcher very long, but I became a researcher to discover the power of aromatic research and what I could do with patients as a nurse. I did not realize that there were different types of regression. I've just thought of it as regression analysis. But tonight, for the first time, I understand that there's linear with that line. You've got curvilinear or, exponential, and then logistic, which is the trickiest of all. Am I saying that right?
Yes.
Or okay. Well, that's comforting. Um, and I think the biggest thing is, first thing you guys need to do is write down on your paper that the Y is the one that stands up and the X is the one on the bottom. Because if you can catch that, then you've caught a lot of it. I think you've done an excellent job. And I think if there are no other questions, we're going to call it.
Okay, Marty, thanks so much.
Thank
And
you.
you're circling in red the points I was talking about, clarified even further.
That was fun tonight, actually
Yeah.
using the pointer. So thank you, everyone. Have a wonderful evening. I'm going to stop the recording and
That wraps up today's session. Thanks for tuning into the AIA Research Academy. This academy exists thanks to the generous support of the Gaffasi Foundation and is here to make aromatherapy research fun, accessible, and relevant. Our mission is simple yet powerful: to educate, inspire, and connect a global community committed to advancing the science of aromatherapy. We envision a future where research is not just part of the conversation, but the culture. The best part, access is completely free. Simply sign up through the link in the description box below. And if you're an AIA member, the Academy is already part of your member benefits, putting powerful resources right at your fingertips. If you're passionate about deepening your understanding of aromatherapy through research, you're in the right place. Be sure to subscribe and hit the notification bell to stay connected with our latest sessions. We appreciate your curiosity, your time, and your commitment to learning.